In 1986, a 53-year-old Italian man named Silvano walked into a clinic in Bologna and told doctors in precise detail how he was going to die. His thalamus was collapsing. He had watched his father go the same way, his grandfather before that. And neurologists today, 40 years and hundreds of published studies later, still cannot explain what the thalamus actually is. The thalamus sits at the geometric center of your brain. It weighs roughly 6 grams. The size of a walnut. Every signal from your eyes, your ears, your skin, your muscles, nearly every piece of sensory data your body collects routes through it before reaching your cortex. Neuroscientists call it the relay station, the switchboard, the gatekeeper. It is a paired structure, 2 halves roughly symmetrical. For over a century, textbooks described it with confidence. It receives signals and passes them along. It is hardware, not software. A wire, not a processor. Silvano knew none of this. He just knew what was coming. His symptoms began the way insomnia always begins: restlessness, an inability to fall asleep no matter how exhausted he was, but within weeks it was something else. He would drift into a half-conscious trance, not sleep, not waking, and snap back, drenched in sweat, unable to separate what had been real. By month 3, he couldn't sleep at all. His temperature spiked and fell without fever. His blood pressure lurched. He began to hallucinate continuously. His cortex was still active. The parts of his brain we associate with thought and memory were still running. What was gone was the thalamus. Scans confirmed it. A prion, a misfolded protein, was eating it, just that structure, selectively. And when the thalamus failed, so did his ability to be conscious in any functional sense. The obvious conclusion writes itself. The thalamus is the relay station. Destroy the relay and signals stop moving. No signals means no experience, no wakefulness, no self. Silvano's case seemed to confirm exactly what every textbook already said. You close the highway, everything stops. Neurologists published the case and named the disease Fatal Familial Insomnia. The mystery they believed was solved. It wasn't. Here's what makes that explanation impossible. If the thalamus is only a relay, if it's wire and nothing more, then other structures should compensate. The brain does this constantly. Stroke patients relearn movement through alternate pathways. Blind people reroute visual cortex to process touch. The brain is extraordinarily plastic, but no one with complete thalamic destruction has ever recovered any function. Not one case, anywhere in the literature. More than that, in 2007, researchers at Weill Cornell implanted electrodes into the thalamus of a man who had been in a minimally conscious state for 6 years. They stimulated a region called the central lateral nucleus, an area no larger than a pea. The man began to speak. He asked for his mother. He began to eat on his own. They turned the stimulation off. He stopped. That is not what a relay station does. A relay station does not have an on-off switch for personhood. Here's what the thalamus actually appears to do and why nobody can explain it. It doesn't just pass signals, it selects them. At any given second, your senses are generating billions of data points. The vast majority never reach your cortex. Something, the thalamus, decides what gets through. But this is the detail that breaks every working model. The thalamus contains no neurons capable of generating conscious experience on their own. By every measure neuroscientists can apply, it is hardware. It is not supposed to determine whether you are a person or a body. And yet, Silvano's cortex was intact when he lost himself. The structure everyone agrees is responsible for thought, language, memory, personality was still there, still running. But without the thalamus filtering its inputs, none of it worked. The lights stayed on. Nobody was home. Researchers have spent 40 years trying to explain what exactly the thalamus was providing. They have not found it. The leading theory is thalamocortical coherence, the idea that the thalamus synchronizes oscillations across the cortex, and that this timing generates unified conscious experience. It sounds clean. Until you notice that deep sleep disrupts thalamocortical coherence too, and dreaming patients are clearly experiencing something. The coherence model doesn't hold. A competing theory, the thalamus is a selective filter, not a timing engine. It prioritizes signal over noise. That doesn't explain the Cornell patient. Stimulating one small thalamic nucleus doesn't restore selective attention, it restores the person. Those are not the same thing, and no existing theory accounts for the difference. Nobody has explained what the thalamus is actually doing. Not in 1986, not in 2007, not now. Silvano reported losing himself days before the imaging confirmed anything had changed. His awareness of the dissolution preceded the scans, which means whatever the thalamus governs, you can feel it leaving before the evidence shows it's gone. What does that tell you about where the feeling of being you actually lives?